Assalamu alaikum guys. So this video is going to be about task 3 of pre-release material 2022. So in task 3 it states that uh, ensuring each booking is the best value. Check that the total for each booking gives the best value and offer an alternative if this is not the case. For example, buying 2 family tickets is better than a group ticket for a group of 10 that includes 4 adults and 6 children. So all it's saying is that if the user is purchasing some combination of tickets, which we did in task 2 when we were implementing this process of booking, the user uh, opted to buy some tickets, and it could be in any combination. It could be multiple adults with child, multiple senior with childs, or any other combination that we can think of. What we have to do in task 3 is we have to suggest whether the combination the user has chosen is the best value for money, and if it's not, then we need to write code that would suggest in what combination the tickets should have been purchased by the visitor, so that it gives the best value for money. Okay, so this is the code for it. Let's see if we can, let's try to go through it and see if we can understand it. So as in the code, they have already suggested that buying family tickets is better than buying a group ticket, and a group ticket is better than buying single tickets. So if the user purchases family tickets, that would be a win-win situation for the user, because it would be the best value for money the user could be getting. So in this code, we are trying to create family tickets based on the single tickets or the group tickets being purchased by the visitor. So initially I have a variable ft which is set to 0, and it's going to contain the number of family tickets that would be computed from the single tickets and the group tickets. Then we have some variables: adult, child, and senior. Adult is equals to a plus ga, a being the single family tickets for adult, and ga being the family GA being the adult tickets that are bought as part of the group. So I've combined these two together to form one variable adult. The same is done for child and senior. Now, in order to find how many family tickets could be created, we need to check whether we have enough child or children's available with us or not, because in the scenario it says that a family ticket has to have 2 adults or seniors and 3 children, and if we do not have 3 children we cannot offer family tickets. So the first thing that we are doing over here is we are checking whether do we have enough child tickets being bought so that they could be converted into a family ticket. Okay, so these are some sample values that I've taken. Let's erase this and we're going to start over with some sample values. Okay, so after checking whether the value of child is greater than equal to 3 or not, if it is, then we're going to divide the value of child by 3, because every family ticket, for every family tickets we need to deduct 3 child, 3 from this variable child. So we could have done with a loop, but instead of a loop I've created I'm using simple maths to compute the value. So let's take a sample value. Let's say we have the value of child as 7. So if the value of child is 7, that would mean that we could create 2 family tickets out of it. So how do we compute that? We could divide the value of child by 3, and it would give us if we divide this by 3, it would give us 2.33, which means that 2 family tickets could be bought with this sample value of 7 of child. So the 0.33 part is the remaining child value that has to be offered as single tickets, because we cannot form a family ticket for it. So the value of ft becomes 2, and the way it becomes 2 is because we have taken the integer part of it. So it's going to be ft would become 2. Then we subtract ft into 3 from child, so that we have a final value of child that has to be offered as single tickets. So over in this particular sample value, the 0.33 part is one that remains behind, one child that remains behind, because out of 7, 2 family tickets are being created. That leaves one child behind. So that one has to be offered as a family ticket. We need to compute that as well. So in this statement we are computing that. After this we have another if statement in which we are trying to find whether the adults are going to be combined to form a family ticket, or whether it's going to be seniors, because either of them could become as part of the family ticket as stated in the previous material. Okay, so in this if condition, I'm checking whether the value of adult is greater than equal to ft multiplied by 2. So if it is greater than equal to ft multiplied by 2, which means we have enough adults to be combined with the family tickets. So let's take a sample value. Let's say that the value of adult was let's say it's 3. Okay, so if it is 3, so let's take 5 first. So if the value of adult is 5, then 5 minus ft multiplied by 2, which is 4, because the value that we've computed for ft for the sample value of 7 was 2. So 2 into 2 is 4. If we subtract that from adult with this sample value, then we have the remaining value as 1. So that 1 has to be offered as a single ticket, while the 4 from this 5 would be combined into form family tickets. So if this is the case when the value of adult is greater than equal to ft multiplied by 2. If it's not, if we do not have enough adults to form family tickets, let's take some other sample values. Let's say the value of adult is 1. Now this condition will become false. Then the code is going to jump to the else part, and it's going to combine that adult with the senior to form one value. So after this is done, let's take some sample value over here as well. Let's say the value of senior was 4. So if the value of senior is 4, then senior plus adult, it would make it 5, and then we're going to reset the value of adult to 0, because it got combined into the value of senior. And then last in line number 16, we're going to subtract ft multiplied by 2 from senior to see how many of the senior tickets are left behind, so that we could offer them as single tickets. So in this current scenario, the value that we computed of senior was 5. ft into 2 is 4. So for senior minus ft into 2, that would become 1. So now we have 2 family tickets that are being offered from the value of child when it was 7, and we have 0 adults left behind, we have 1 child that's left behind, and we have 1 senior that's left behind. So we need to offer that 1 child and 1 senior as single tickets, and the remaining of the tickets are being combined to form family tickets. I hope that made some sense. So the value of FT that we computed over here are added with is being added with F being the family tickets that the user opted himself or herself. This FT is what we are computing. The code is computing that what the user should have purchased, but F is what the user has selected himself. So we have combined both of them together to form one value in F. So this would be at the end, this would be used to compute the total cost as an alternate cost, and we're going to check whether it's less than the total cost that we computed in task 2. But before that, if there are enough adult, child or seniors that are left behind, uh, if the values of adult, child and senior that's left behind are combined together into one value of RP being remaining people. And if that value is greater than equal to 6, then we're going to suggest that the user should purchase those as a group ticket, because it would offer a better value than purchasing single tickets. So I'm combining the value of adult, child and senior into one as RP, and I'm checking over here whether the value of RP is greater than equal to 6 or not. If it is, then that value is combined into group, and the values of adult, child and senior are reset to 0, because they have combined into one value of RP. If it's not greater than equal to 6, of course, then the value of adult, child and senior would remain, and they would be offered as a single ticket. After that, we are checking whether the number of days selected was 1 or 2. If it's 1, we are computing an alternate cost with the values that we computed over here. If it's 2, then we're computing the alternate cost for a 2-day ticket. And at the end, we are comparing the value of alternate cost with total cost. If the total cost that we calculated in task 2 is greater than the alternate cost that we are calculating over here, then we're going to suggest that the user should be purchasing the tickets in this particular combination that we have computed over here, so that the user gets a better value. I hope this all made some sense. If you have any questions, you can of course you can send me a message, or you could comment on the video, and I'll try to answer as fast as possible.